Hi, everyone out there in the virtual world. Today's lesson is going to be on density again. So we just finished our density assignment. And today what we're going to do is look at some application of what we learned in the density assignment. So first of all, I want to switch my camera view, and what I want to show you is a density column. So I'm going to show you that first, and then we're going to talk about what that is. So if you look at the picture, and I'll switch over to here, you can see there are 5 different layers in this density column. And every single one of these is actually a liquid. So there are various liquids, mineral oil, corn syrup. So they're all liquids, but they are poured very carefully on top of one another. And because their densities are different, they can actually layer like that. So I'm going to turn this around so that you can see what each of these are. So all the way down here at the bottom, you can see that we have light corn syrup, and notice it has the highest density. Well, you'll see that as soon as we look at all of these. So it has a density of 1.33 grams per milliliter. Then sitting on top of that, you'll see there's a blue layer. That blue layer is Dawn dish soap, or Target brand dish soap. So that has a density of 1.06. Then the green layer, which you can see right here, is water. I added food dye to the water, so the density of this water is about 1.00 grams per milliliter. Then on top of that, I have some mineral oil that is layered on top. And notice that its density is less than that of water, so 0.8 grams per milliliter. And then finally, all the way at the top here, I have ethanol, or better known as ethyl alcohol, and its density is even less than mineral oil, so that's why it's sitting on the top. Hello again. So we're going to switch it back to me for a minute here. So I showed you that density column. Today what we're going to be working on is a density lab, and it's actually a density lab for solids, unlike the liquids that we just saw in the density column. So the density lab for solids is going to have us look at the density of about 15 different compounds. And what we're going to do is we are going to record, so the 2 components for density are mass and volume. And what we're going to do is we're going to record those 2 components for each of these 15 samples. And then we're going to use the data that we record to try and identify what they are. So just showing you a picture of what the samples look like right now. They are unidentified, and you can see there's a bunch of different colors. They're all cylinders. They have different heights. Some of them are metals. A lot of them are plastics. So what we're going to do is we're going to take a look at each of these, and we're going to put them on the balance at first, and then we're going to try and measure the volume by water displacement, which we'll talk about as well. And we hopefully will get all of the data that we need. So before we take a look at our first object, I would like to go over with you what this lab looks like. So I'm going to share with you the density lab. And right now, if you're looking at my screen, you'll see obviously density lab. It says the density is a physical property of matter. We talked about this, and it's the ratio of mass to volume. So I'm going to let you read through the purpose and the materials on your own, and obviously the safety precautions. You're going to be pretty safe sitting at home and watching this. But let's go down to the first data table. So the first thing that I want you to notice is that above the data table, I have a data table description, which tells the reader what they're going to find in the data table. And then in the data table, we have 5 different columns, and the first column all the way on the left talks about what the object is, so how we're going to describe that object. And then when we collect our data, we'll be putting in the mass data and the final volume of water data. Now, if you notice, the initial volume of water is already filled in for you. So what I did was I went ahead and I filled each of those graduated cylinders that you see at the front of the table with 25 milliliters of water. So the 25 milliliters of water is important because we needed enough water so that our sample was covered, but not too much that the water would overflow the top of the graduated cylinder or go beyond the graduation marks. So 25 seemed like it was a good in-between for that. So each of the samples has a graduated cylinder behind it. Each of those graduated cylinders starts off with 25 milliliters. When we put our sample in, the level of the water in the graduated cylinder is obviously going to go up. The amount that it goes up by is actually the volume of our sample. So we're going to record the final volume of the water, and then we'll subtract out that 25 to get the volume of the object itself. If I scroll down further in the lab, you're going to see that we have two objects that float, and we'll talk about why you cannot use water displacement to figure out the volume of an object if it's floating. So I'll show you those two as well. And then finally, if we slide down to the calculations part, this is where we're going to put our final results. And then if you scroll down a little further, this is where we are going to show our work. So each of these boxes corresponds to one of our 15 samples. And what we're going to do is collect the mass and volume data for each of those. And then we can put them into here and calculate our work. So now what we're going to do is I'm going to go through about 5 or 6 samples together with you, and then I'll provide the data for the rest of the samples so you don't have to listen to me for 2 hours as we do this lab. So we'll be together for the first 6 samples, and then I'll go through exactly what you need to do, and then you can do the remaining 9 samples on your own. Okay, so we are back at our balance, and I am going to take a look at our very first sample. So our first sample is this clear piece of plastic. Some of you might already know what this is. So I'm going to put this sample on the balance, and we're going to record our mass for that sample as 26.12 grams. So if I go back to my document here, we're going to be working initially in table 1. So we have a mass of 26.12 grams. So we're going to put that right in here. And now I'm going to carefully slide that cylinder into the graduated cylinder. If I grab my graduated cylinder, initially the graduated cylinder has 25 milliliters of water in it. Now, when I add the cylinder, the plastic cylinder, to the graduated cylinder, notice that I tilt the graduated cylinder. The purpose of that is to allow the object to slide in carefully. 2 bad things can happen if you don't do that. The first is, especially if you have a metal object, these are glass. So a metal object will crack the bottom of the graduated cylinder and spill out the water. The other problem is if I just drop it in, some of the water might splash out. And that would change the volume reading on the side of the graduated cylinder. So what I'm going to do is I'm going to slide this in very carefully so as not to spill any of the water. Then I'm going to lower my body so that I'm at the height of the graduated cylinder and I could read it directly across. And I'm going to read the graduated cylinder's volume as 47 point, and now that we know about significant figures, I'm going to read it as 47.1. So the volume, total volume of the cylinder, the clear cylinder, and the water that was in the graduated cylinder, we're going to record that as 47.1 milliliters. So now, in order to find the volume of the object, we are going to subtract those 2 numbers, so 47.1 minus our 25 initially, and we're going to get a volume of 22.1 milliliters. Those are the only 2 pieces of information that you need in order to go on to the next part where we're going to substitute it into our calculation. So again, we're going to slide down to where our calculations are. And we're working right here in this first box with the clear cylinder. So we have 26.12 grams. We have a volume that is equal to 22.1 milliliters. Here is our equation for density. So now into the top part here, I'm going to type in 26.12 grams. Into the bottom part, I'll type in my 22.1 milliliters. Notice, every single time that I write down a unit, I also have, or a number, I also have a unit with it. Number and units, very important. There shouldn't be numbers just floating around without units on them. So now we're going to calculate the density of this. So I have 26.12 divided by 22.1. I get a density of 1.18. So I'm going to type in my density, 1.18 grams per milliliter. Now's the cool part. Now, just based on that physical property alone of density, I can go to my list of possible choices here, and I can find out that my first one is acrylic. So acrylic is 1.18 grams per milliliter. So just by finding the density of this unknown material, I was able to identify what it is. So I'm going to go back to table number 3. So my calculated density was 1.18. We identified the sample as acrylic, and the accepted value was also 1.18. The accepted value is what's off that table that we just left. Okay, at this point we are ready to move on to our second object. So I'm going to slide the camera back over. Here is our second object. We have this black piece of plastic here. So we're going to start by getting its mass. So this has a mass of 29.89 grams. So I'm going to go back up to table number 1. 29.89 grams. Now I'm going to slide that object into a graduated cylinder. Again, that graduated cylinder has 25 milliliters of water in it. Now, if you're wondering about how to read this, remember we learned about significant figures. So you can see on the graduated cylinder there are markings for individual milliliters. So here's 20, here's 30. So each one of these smaller lines represents 1. Those are certain digits. And then you have to go 1 digit beyond that to 1 estimated digit. So that's why these are going to be estimated to be 25.0. And then when I give you the reading, it will also have that 1 estimated digit. So once again, I'm going to tilt this, allow it to slide in gently. Put it on a nice level surface to read it. And we wind up with a volume of, looks like 46 point, I'm just going to estimate 46.1. So our final volume in this case will be 46.1 milliliters. When we subtract these, we will get a volume for the object that is equal to 21.1 milliliters. And now we can scroll down to, well, first I'm going to jot down these two numbers, so 29.89 and 21.1. We can scroll down to our calculation section. So our mass, 29.89 grams, and our volume in this case was 21.1 milliliters. So our density, 29.89 grams. Just gonna move this over a smidgen so it's nice and neat. And then 21.1 milliliters. And then dividing these 29.89 divided by 21.1 and we get 1.42 as our density. 1.42 as our density. So if we look at the values on the next page, actually it's right at the top there, 1.41. So it's acetyl. So we're going to put in here our value, which was 1.42. And the value for this is, the accepted value was 1.41 from the chart. Okay, so we finished our second sample. What we're going to do now is move on to our third sample, which is the one that looks strangely like wood. So if I switch my camera, take a look at this over here. Here is a picture of what this sample looks like. You can tell it's very wood-like. So I'm going to drop this onto our balance. So it looks like we have a mass of 15.17 grams. So we're going to type that into our data table. So now notice that it's not in this top part in data table number 1. And I'm kind of giving it away here, but you're going to see that this object will not sink, and we cannot get its volume by water displacement. So instead, we're going to go down here and we're going to write 15.15 grams. Now, just to show you why you cannot use this method, so if I drop this in here, you'll notice that the wood floats. Let me make this a little bigger. You'll notice that the wood floats. So you can see it sticking out above the surface of the water here. So that means if we measured the volume where the water is, that would not be very accurate because some of the wood is not underneath the surface of the water. So we couldn't use displacement to solve for the volume of this piece of wood. So instead, what we're going to do, I'm going to pour this water out. Instead, what we're going to do is we are going to use a centimeter ruler that looks like this. So you can see the graduation marks go all the way down to millimeters. So we should have 2 decimal places with our measurements here. So I'm going to measure first the diameter of the object. So being careful to line it up, not with the edge of the ruler, but with where the 0 is. So lining this up on the ruler, it looks like our diameter is going to be about I have 2 decimal places here, so 1.58 centimeters. So I'm going to go and add that to our chart. So the diameter, 1.58. We're going to divide that in half. So dividing that in half, we're going to get 0.790-ish as the radius. So the diameter is the distance across. The radius is the distance from the center to the outside edge, so about exactly half the diameter. The other piece that we're going to do now is I'm going to measure the height of this. So if we, again, hold it so that the bottom where the first marking is starts, we're going to get a height for this that's about it's just over 10. So let's go 10.05 because it's not quite 10.1. So 10.05 as the height of our object. Now, if you remember, the equation for calculating the volume of a cylinder is pi times r squared times h. So pi times r squared times h. That'll give us the volume of the object. So what we're going to do here is I'm going to type that into my calculator. Pi times 0.79 squared times 10.05. And we get a volume of about 19.7 centimeters cubed. Now, centimeters cubed and milliliters are equal to each other, so that really doesn't affect anything except for the unit. So I'm going to write down our mass, 15.15, and our volume 19.7. We're going to scroll down to where we enter in our calculations. So we have our wood cylinder here. So the mass is 15.15 grams. The volume is 19.7 milliliters. Or in this case, because we measured it in 3 dimensions using a ruler, we could write centimeters cubed. So we're going to get a density for this, 15.15 divided by 19.7, and we get 0.77, 0.769 grams per centimeter cubed. So now we're going to go to the next page. We have 0.769. And if you notice, the closest one to that, which makes sense, is this maple. So that's 0.77 grams per milliliter. Again, grams per milliliter and grams per centimeter cubed are the same. They're synonymous with each other. So for the wood, we got an answer of 0.769. We said that that was maple. The accepted value is very close, so just 0.77. All right, we're going to go back. We're going to do 2 more together. So the next 2, we're going to go back to our data table number 1. I'm going to skip over the red one. I'm going to give you the data for that, and then I'm going to let you calculate that and see if you could do that. So at this point, I'm going to fast forward the video so that you can see me do that really quickly, and then we will be back when I'm ready to do the next regular object. Okay, we are back. So now we're going to take a look at the next object, which is our orange colored object. So I'm going to once again switch it over to the balance so we can take a look at that. Here's our orange. Feels just like an orange plastic. I'm going to put our object on the balance. We see that it is 18.73 grams. 18.73. So we're going to type that into our table here, 18.73 grams. And then once again, we're going to get the volume by water displacement because this object does not float. So we can once again use this to get its volume. I'm going to tilt this, let it slide in there carefully. We have a reading of about 43.2, so 43.2 milliliters. So when we subtract these, we'll get a difference of 18.2 milliliters. And now we're ready to go and type this into our work section. So I'm going to slide this down. I'm going to skip over the red one because you're going to do that one on your own. So we're going to jump to the orange one. 18.73 grams is my mass. My volume is 18.2 milliliters. 18.73 grams. 18.2 milliliters. We get a density value of 1.03 grams per milliliter. So it looks like this is an example of polystyrene. Polystyrene is 1.03 grams per milliliter. We had that one exact. Okay, so we're going to try one more example together. So I'm going to go back up to data table number 1. We're going to look at the yellow object together. So move the camera over. So we have 24.05 as our mass. Try that again, 24.05, there we go. And to get our volume, here we have it in there. So it's about 40, 41, 42. I'm going to go with 42.5 as our volume. So in here, we're going to type in 42.5. So for our volume, we're going to have 17.5 milliliters. I'm just going to jot down these two numbers really quickly, 24.05 and 17.5. We're going to go down to our calculations section. Oops, forgot to write it up here. Wind up with a density of 1.37 milliliter. Okay, so we scroll down, we look for 1.37. It's 1.32. Here's 1.38. Here we go, 1.37, exactly. 1.37 is PVC. Now, again, some of these are close. If you're off by a little bit, you might have picked a different material. So it's very important to be as accurate as possible. So 1.37 PVC. And we had that one spot on. Okay, so at this point, what I'm going to do is I'm going to return us to table 1. I am going to collect the mass data and the final volume data for each of the remaining samples. I am going to fast forward this so that way you don't have to look at it in this slow motion here. And then as soon as I'm done, I will share with you all of the values that I have. So here we go. I'm going to switch over the camera one last time here. Okay, I am back. We have completed our data table. So at this point, what I am asking you to do is to first calculate the volume of each of these objects by subtracting. Then once you have done that for each of the objects, you're going to go down here and you're going to complete this table by inserting your mass, volume, and then completing the calculation. Then you're going to use the table that follows to identify what the material is. By the way, there will be some duplicates, so you might see a material that we've already used again, so if that happens, that's okay. And then you're going to put your final answer into here, along with what you believe it is, and the accepted value for that, which again is coming from that table on the last page. Alrighty, I hope that was at least somewhat enjoyable. I know it's not nearly as fun as being in lab and doing the experiment yourself. However, I think it was pretty cool. So thank you very much, everyone, for watching. And what we are going to do next is complete the rest of the lab. So until I see you next time. Bye-bye, everyone.